My name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst Podcast, a show about application, development, and management at scale. Thanks for joining us. The New Stack thanks Buoyant for sponsoring our Pancake breakfast at Kubecon plus Cloud Native Con in Austin, Texas. Learn more about Buoyant and the development of its open source service mesh technology at buoyant.io. Thank you all for joining us this morning. My name's Alex Williams. I'm founder and editor-in-chief of the New Stack, co-owner of the company with the better other half, Judy Williams, who really put this event together. I want to give her a big hand, and the team here at the New Stack. She really did a great job. But first of all, before I really get started, I want to thank Buoyant, who sponsored this Pancake breakfast this morning. And Buoyant has just introduced Conduit, and William Morgan is going to tell us more about that in a little bit. Our discussion this morning is all about service mesh technologies. What is a service mesh technology? Why is it important? Why are we hearing about it now? So we're going to really focus on the fundamentals of the technology, and I really encourage you to ask questions. This is your chance. And to facilitate that, if you ask a question, you get 5 additional raffle tickets for the big prize that we're giving out. And I'm going to turn it over to the expert here who knows all about this special prize.
No problem. I think Judy has it back there. But today we have a Pulse Rain M10, which is a 100% open FPGA Arduino development board. So it's programmable. Since it's an FPGA, you can do anything you can on an Arduino. You can program it on Arduino IDE. And that was donated to us by CrowdSupply, which is a really fantastic crowdfunding site for open hardware projects.
All right. So I want to introduce the panel, and we'll get started right away. So why don't we go from left to right?
Hi, I'm Borys. I work for National Center for Biotechnology Information, essentially government. It's a lot of legacy. It's scary. There are monsters, zombies, and all that stuff. But we're using service mesh to bring some goodness into this world, and it works so far.
Hi, I'm William Morgan. I'm the CEO of Buoyant. I used to be an engineer, but now I'm just the beautiful face of the company.
Hi, is this on? Hi, everyone. I'm Kris Nova. I work for Heptio. I'm a developer advocate there. Yeah, hi.
I'm Joab Jackson. I'm the managing news editor for the New Stack.
Great. Well, thank you all. So I want to take a quick poll here. How many people would consider themselves developers in this crowd? How many people would consider themselves in operations? Both? Other? What is your other role? Okay, yeah, that says it all. All right, so we really want to have a lot of fun here and just encourage everyone to ask questions. Again, you get 5 raffle tickets if you ask a question. But I want to just get started by asking William a little bit about service mesh technology. What is service mesh technology? Why is it important? And tell us a little bit about what you just launched yesterday in Conduit.
Sure, yeah. So the age-old question, what is a service mesh? Little known fact, the pancakes this morning were not made with a service mesh.
Dang.
And the results speak for themselves. Yeah, so the service mesh, it's not ultimately a new thing. It's a new word that's being applied to kind of a bunch of ideas and algorithms and whatever that have actually been around for a while for pretty much any company that's had to move into microservices. And what's making the service mesh kind of relevant, suddenly as a separate thing is the advent of things like Docker and Kubernetes, orchestration and containers, and this cloud native kind of ethos for how we build software. So what the service mesh is a software kind of infrastructure layer that manages the runtime communication between services. So in a big multi-service or microservice architecture, you've got A talking to B, talking to C, talking to D. The way that communication happens at runtime turns out it's quite complex. And once you have things running on Kubernetes and you're all Dockerized and you're like, almost ready to be cloud native, what you often find out, at least what we found out in my kind of miserable past experiences, is things start breaking really rapidly. And so you need to instill a certain amount of sanity to the runtime aspect of service communication. That's really what the service mesh gives you. In practice, like you implement it as a bunch of proxies that kind of run alongside your application code, and if you do things in the right way, then the application doesn't really have to care about it. So ideally, the developers get to have this beautiful lifestyle where they just say, okay, I'm service A and I talk to service B. And then you as the operator end up with a bunch of, or as a kind of platform owner, end up with a bunch of control that the service mesh gives you. So that's kind of the not so short summary.
Okay. So tell us about Conduit and why, and you guys had previously had, you still have Linkerd, right? But why did you develop Conduit? Maybe tell us about the difference between the two.
Yeah, so we did something crazy, which is that we made another service mesh. So in order to answer that question, which is an excellent question, I kind of have to go into a little bit of the history behind Linkerd. So when we launched Linkerd, I think it was the beginning of 2015, so under 2 years ago, about 18, 19, 20, maybe 20 months ago, we didn't really know what to call it. And we called it an application proxy or application router. We called it an RPC proxy. And what happened was we released it into the wild, and we started seeing people use it in this very particular way. Companies and organizations like the NCBI use it in this particular way, which later on, after a lot of kind of brainstorming, we decided, okay, we're going to call this the service mesh. And it was the way they were deploying this. And at the time, the market was quite fragmented. So a lot of people were on Mesos, a lot of people were on Nomad, a lot of people were on Kubernetes, and a lot of people were still, struggling with Zookeeper and kind of, and actually that's still largely the case. And so as time went on, we saw this particular use of Linkerd in the service mesh context, and it was great, and we got a lot of adoption, and we're feeling very happy because, open source is like a horrible thing to do. One of the few rewards that you ever get is adoption, like users in the community, and people are using it, and you feel good. So that felt great, but what kind of happened with Kubernetes especially is that, what people really wanted to do with Linkerd, one of the use cases that we really wanted to support was this sidecar mode where you can, stick Linkerd instances right next to every application instance. And there's all sorts of nice reasons why you want to do this, especially around security policy and that sort of stuff. And Linkerd had kind of, Linkerd has kind of a little bit of friction, which is that Linkerd is built on some very powerful components that also tend to be quite heavyweight. So Linkerd is built on top of a library called Finagle, which powers all of Twitter and SoundCloud and Pinterest. It's built on top of Netty. It's built on top of Scala. It's built on top of the JVM. These are all components that are excellent at scaling up. So if you give Linkerd like a ton of memory and a ton of cores, and man, it can really crank. It can just handle insane amounts of traffic. But in the sidecar mode, you kind of want the opposite of that. You want something that, only handles 1,000 requests per second, or something, which is quite small by Linkerd standards. And you want to do it in a very small amount of memory because you're deploying a lot of these. And that's, that's kind of the point of friction that we were at maybe, 8 or 9 months ago when we realized that, okay, for this particular use case, it was going to be difficult to really adapt Linkerd, right? There's lots of features. You can always add more features. You can always build more integrations. But squeezing the JVM down to 10 megs of memory or whatever, that's not going to happen. So that led us down the path of Conduit, where we wanted to really focus on the Kubernetes use case, Kubernetes sidecar use case. And we also, when you have this opportunity to do something from scratch, we also wanted to take into account all the lessons that we've learned over the past, it's been 18 months of Linkerd being in production and, around the world. We've learned a lot of lessons. In fact, the world has learned a lot of lessons. So we wanted to take into account a lot of those lessons too. So that's kind of the genesis of Conduit. Linkerd is something that we continue to support and maintain, and we love it, and other people love it too. It's never going to go away. Conduit is really focused on this one particular case that we think is really important, but that Linkerd has trouble addressing.
I think we just had a service mesh miracle. Some more pancakes just arrived. Whoa, right.
Must have installed
That's
Conduit.
what I'm talking about. You called it out. You said, I'm not sure if service mesh, can bring us more pancakes, but I think it just did.
The latency was unacceptable.
That's the true power of the service mesh.
The latency was unacceptable, Joab said. I also want to, so now's a good time for a question. And Libby Clark, who is our editorial director and co-host for this event, she has the mic. And so now's your chance to ask a question about service mesh technologies. What is a basic question you'd like to ask? We got one right here.
So what's the main differentiator between Conduit and something like Istio?
What's the main difference between Conduit and Istio?
And,
Great.
Istio also has very big backing from Google and IBM, and so where do you see competing with Istio, or I would like to know the technology differentiators between the two?
Yeah, that's a really good question. To tell you the truth, I'm kind of half familiar with Istio. We tracked it quite closely in the beginning, and then kind of less and less as we started investing in Conduit. So I don't really have a great answer for you. I would encourage you to try them both. I think from my perspective, one of the things that's nice about being at a company, as opposed to being a group of engineers in a room, which we also are, but we're also a company, is we get a lot of feedback from customers, and it's very clear for us, how exactly we're going to survive, right? And the way that we're going to survive is by building something that our customers want. And so that's really the genesis of Conduit. These are the things that people have been asking us for, the use cases that they want, and all of that goes into the design of the product.
Are you planning Conduit to be a replacement of Linkerd, or is there a migration path, or will the two coexist? What's up with that?
Yeah, so the two will coexist. I think in the long run, we'd like to have a migration path for our existing Linkerd Kubernetes users. But if you really don't want to, that's fine. Linkerd will always be around.
Kris, you're a longtime Kubernetes user, and you've been actually quite involved in the development of Kubernetes. How do you see the evolution of service mesh technologies kind of in the context of Kubernetes?
Well, I think the fact that we even have a service mesh and we can even have conversations about things like sidecars is sort of a testament to the patterns in Kubernetes working long term. Really, if you're boiling down a service mesh, it's another piece of software that you run in the same pod that solves like layer 3 and layer 4 concerns of network routing. But ultimately, it's just a software encapsulation of an advanced problem that we're solving. And really, this is what Kubernetes is good at, is allowing users to encapsulate custom business logic, or in this case, custom network logic, into software and run it in a very flexible way. So when I hear people talk about service mesh, back in my mind, I'm always like, yay, Kubernetes is doing the thing we designed it to do from day one.
Anyone out here using service mesh technologies? In the back? Would you mind telling us how you're using it? And Libby, I think the gentleman in the sweatshirt in the back here.
This is a lesson never to raise your hand.
Oh, don't say that. We want people to ask questions.
So today, Istio is actually technology you're using for service mesh. It's really just to basically get some traffic analyzation patterns and find out actually what's happening in terms of really just analysis.
Okay. Questions? We have a question right here.
So what tools do they use to, like, he was talking about traffic and analyzation and stuff. What other tools would you have, like, with Conduit and I guess Istio and the other service meshes that are out there?
For, like, traffic analysis? Yeah, so a lot of what we do with Linkerd and with Conduit is, I think where the service mesh sits, it has access to a particular type of telemetry information that you can't otherwise really get out of Kubernetes, which are kind of the top line service metrics, things like success rates and latencies and request volumes. Those things are, you have to look at the traffic in order to do that. So the first kind of basic line of things that the service mesh can give you is, well, how are my services, performing? What's the success rate, right? What's the latency? Is that increasing? Is that decreasing? And that's kind of the stuff that you want to be woken up at, at 3 a.m. for anyways. Like, CPU usage is going up. Well, okay, you can still kind of sleep through that. Request rate's dropping. All right, you want to wake up. So that's the first I think there's also kind of this, what services are talking to which other services? That's typically a relationship that sometimes is captured in the code, but often is only really expressed at runtime. And that's something that service mesh can capture that you don't have, it's not captured at the container level or the orchestration level.
So is Conduit trying to solve the needs of the data plane, control plane, or both?
Yeah, that's a great question. So it is both. It has both. So there's, for those who don't know, and Matt Klein has a really good article about this. In the service mesh, it's pretty natural to segment the functionality into these two layers. Or there's the data plane, which is actually like the proxy tech itself that's transmitting the requests and instrumenting it and doing retries and timeouts and that stuff. And then there's a control plane, which is sitting on top of all the proxies and providing this uniform layer of control and uniform kind of API over all that stuff. Conduit does both. Actually, Linkerd has both too. We have, I think when we talk about Linkerd, we often talk about it in terms of the data plane, but it actually has a control plane called Namerd, just kind of a terrible name, and we don't talk about it a whole lot. In Conduit, one of the things we wanted to fix was just be way more explicit about that relationship. So there is a Conduit control plane that runs in a Conduit namespace, and then there's the data plane that runs along, the proxies that run in the pods.
And I think this pattern is super important because we saw this originally come out of Kubernetes in like 2014-ish, which was we sort of have this control plane that behaves as the brains of the operation and sort of manages all of these worker subsets. And in the case of Kubernetes, we have nodes, and the control plane goes and manages those in a declarative way. And I see a lot of those same patterns popping up in Service Mesh. And I think it's a good pattern in overall engineering and architecting, and seeing it implemented on the network layer is always super exciting.
Before we ask any more audience questions, Borys, I'd like to ask you, tell us about how you're using Service Mesh technology and why.
Well, actually, I think that we're a little bit different from many of folks around here because we're not as advanced in Kubernetes and other stuff yet. On one hand, on the other hand, we clearly seen Service Mesh being a path for us to go there. Because when you're dealing with a lot of legacy, you cannot just throw it away and say, hey, we don't care about what we built within the last 30 years. We're going to build everything from scratch. Not going to work, right? So what we're trying to do, we're trying to wrap everything we have so far built in the last 30 years into a service mesh while we keep building our new stuff. And then while we keep doing everything that our engineers are doing, we're trying to move forward from our old bare metal provisioning scheme to cluster scheduling and Kubernetes in particular. So for us, is that silver thread that we're trying to grasp, to be able to cope with the pace, how the world is moving.
Great. Can I add something to that, Alex? When Jen and I were brainstorming about who to feature as a customer, we wanted to ask Borys to come up for a couple of reasons. One, because NCBI, I think, has a mission that I think is a great mission. It's not a horrible San Francisco startup like Buoyant. It's actually something that's trying to do good for so we're trying to help the world too, but in a very direct way. The function that the goal of the NCBI is to provide access to bioinformatics information.
Oh yeah, helping everybody in this world.
Right. Yeah. So that that's like a powerful mission, and it feels good for us to be able to play a role in that. But also the other reason was because the NCBI has this particularly complex case of decades of legacy technology that is a very real use case, and it's a nice contrast, I think, to kind of our the startup mindset that we often get in, where it's like everything's greenfield and we're just introducing Kubernetes, and okay, we got 500 lines of code and we're ready to go.
Yeah, so in some sense, as I mentioned, NCBI has pretty long history of a couple of decades. And back in 90s, we had some kind of service registry built in-house, as well as a tracing system. And, well, it was working in some way. Well, it's actually still operating. And what's important for us is that when we started using Linkerd and actually Namerd, we realized that it's actually an amazing fit for us because we can keep using our old technologies as our own in-house built service registry and tracing system together with Linkerd. So we're not throwing away our tools, we just start to use them in a new way. and that's really important for us.
Great. Questions? We want, yes, there's one right here.
Hi, good morning. I work for a company where we have a lot of legacy systems, obviously, right? We still have applications which are using ESP data path. We have application which uses MuleSoft as really like, for the service registry itself. And within the process of converting some of those applications, Dockerizing, most of applications are WebLogic, WebSphere, newer applications are on Tomcat. We're in the process of modernizing those applications to containerization, essentially. There are like solutions which are available. We still have network which are on 7K Cisco as well as 9K switches. The question that I have is how can service mesh technology help organizations like us who cannot really switch over to the microservices based architectures like your organization can adopt to? How can this really help us move to a journey which really will take in 3 to 4 to 5 years of time to an architecture which is really the modern day architecture, but in the meantime helps us stabilize our architecture, helps us really with the process through which we can deploy our application faster through stabilization of environments and things of that nature.
Yeah, so the question was how can the service mesh help in this complex, real world use case of we've got a lot of existing legacy systems and several strata, over the years, and we're not just dropping in Kubernetes and here you go, let's rewrite everything from scratch. And I'll tell you, I love these situations because this is real life, right? So it's very rare to really have a greenfield environment. So I think, and we see a lot of use for Linkerd, especially in this case. This is really one of Linkerd's strengths, is that we want to integrate with everything in order to do this sort of stuff. I think the most direct way that the service mesh can help in these situations is by introducing kind of a decoupling layer between, where I as a service am running and where the thing that I want to talk to is running. And so by introducing the service mesh to capture that, so, the local application one just talks to its local service mesh and kind of trusts that the request will get delivered. Then you have the freedom to migrate these services kind of at your own pace across the various technology boundaries or the various infrastructure boundaries. And we see people using Linkerd to kind of introduce Kubernetes into an existing environment or to merge Zookeeper on top of Kubernetes in some kind of horrible way, but that makes a lot of sense for them as a company. So I think that's the most direct value.
I think also there's something to be said about having the sidecar model here, that when we do have a service mesh bit of software that's running next to your application can pretty much be dropped into a container. There's a big asterisk there for everybody in the Java community. I think it's a powerful pattern, and as an engineer, if you're just okay, I can effectively replicate an environment, sure, it's not going to be the same DNS endpoint, but it's going to be something meaningful to me, and then I can get that and run that and scale that horizontally. I think that's a really scalable pattern, and that makes it easy for people with legacy systems to move into this cloud-native space.
Joab, I'm sorry, I was going to ask a quick question to Joab. Joab, we've done some coverage in this space. What are some of the tell us about the coverage you've seen, what the writers have been talking about. What is it that you're hearing outside in the community, from the technologists who are, actively involved in this?
Well, we are starting to see a bit of a race going on between Envoy / ISTO and Linkerd. I guess a war between two camps of different ways or different approaches of doing the same problem. There's also a lot of talk about, well, how's this different from an API gateway?
Right.
So, we're starting to see a bit of that as well, but there is a great deal of interest going on. Even compared to Kubernetes, it's almost as if the service mesh is taking off on a topic as its own. And I was talking to William, and from what I understand, a service mesh doesn't require Kubernetes or even a container infrastructure. You can do a service mesh with serverless or virtual machines. Am I correct on that?
Yeah, that's right. In fact, if you look at Linkerd, it basically treats Kubernetes as a service discovery endpoint, in the same way that it treats Zookeeper and Console and etcd and whatever else. So from the pure tech perspective, it's not a hard requirement. From the adoption perspective, that's kind of the more interesting question. It's like, okay, in which situations does the service mesh start making a lot of sense, as opposed to client-side libraries, as opposed to just ignoring the problem.
So this, for an organization that is heavily invested in VMs, a service mesh would be a good way of moving to even more of a service-oriented architecture, I take it.
Yeah, I think that's right.
Yeah, I think you would be able to implement the service mesh long before you started looking at container orchestration. And then you would be able to effectively get your application working with that layer, and then you could just drop it into the cloud native space in Kubernetes or orchestrator of your choice.
Yeah, we actually had Linkerd deployed and running and routing some production traffic in our organization long before we had first container or cluster scheduler launched for the first time.
Awesome. Alice, I wanted to follow up with one other kind of point on the earlier question around data plane versus control plane. One of the things that I'm really excited about with Conduit is we've really, by decoupling those two things, very explicitly from the start, it's actually given us a lot of flexibility to make different tech choices for the data plane versus the control plane. One of the things that our users and customers have really been adamant about is security. And that's a paramount concern really in the data plane, where you're actually being exposed to, not only the request data, but PII and, HIPAA compliant data and all sorts of other stuff. So we made a decision about 6 months ago, which felt honestly quite risky at the time, to build these proxies in Rust, which is it's still a fairly new language. In the past 6 months, I've seen a lot of adoption now. Firefox is out with Rust, and Dropbox is using Rust in production, and all these companies are using Rust. So I'm feeling much less scared about it. But 6 months ago, it was really kind of a risky decision. But it's really paid off for us, because the data plane now, like the Conduit proxies, not only are they native code, so they're incredibly fast and incredibly lightweight, and right now I think they're like 3 megs of memory, RSS each, and sub 1 millisecond P99. That'll probably get a little worse as we introduce more features. It's not a strict apples to apples comparison. But we also get the memory safety guarantees of Rust, so we just sidestep this whole class of CVEs and buffer overflows and like Cloud Bleed style things, which is something that we had with the JVM, because the JVM is explicitly managing the memory, but of course at quite a different trade-off. So I'm really excited about that. That's given us, there's been a whole lot of positive feedback around that.
Let's get a question.
So I heard that on client side it's not big overhead, but what about data plane? Is it like overhead? How big cluster can you run? How many container spots can you run with service mesh? That limits you in any way.
Yeah, so how big can your cluster get with the service mesh? I think cluster size doesn't really get affected, because the data plane itself is basically distributed. The proxies don't share information except by way of the control plane. So it's really more a function of how heavyweight are the proxies.
I think the question might be related to control plane, actually, because you also need to scale control plane, and depending on the mode of communication between data plane and control plane, there might be different problems involved. For instance, if you take Envoy in its at least first version, the delay for propagating updates about service availability to data plane instances was quite substantial, as it was like just eventual consistency, as compared to Linkerd and Emerd, where we had like just tens of milliseconds. So yeah, I think that's an important point, actually.
Yeah, that's a great point. So I guess to answer your question, I don't know. You should scale pretty high. Try it.
Question.
1 million.
Can you let us know that like few top features for service mesh, basically?
Yeah. Oh, that's a really good question. I should have done that in the really beginning. So like, why? I said what, but why? Why are we even talking about this thing? Okay, what does the service mesh give you? I think there's 3 layers of things that it gives you. The first thing is it gives you visibility, right? And visibility at the level of success rate, request volumes, like the latencies, like the top line service metrics, okay? And without having to change your code, which is really nice, especially if you're in a polyglot environment. Number 2, it gives you reliability semantics, so things like retries and timeouts and deadline propagation and circuit breaking and, load balancing based on, latency. So if, one of the wonderful things about the cloud is that everything's fucked up like 50% of the time, and like half your instances are down, or half of them are really slow, or half of them are fast but are returning errors. and the service mesh is designed to handle those situations through a combination of circuit breaking and load balancing and all that other fancy stuff. And then the third level, I think, is kind of the security level where you can start, the proxies don't have to just proxy everything. They can start enforcing policy, right? And that starts making a lot of sense when you want to do, express policy in terms of services or in terms of calls between services, but things are being rescheduled by the orchestrator, and so it's really hard to use kind of layer 3, layer 4 semantics around that. And so those are the 3 layers, and it gets all wrapped up in my mind in kind of this core value prop of taking that kind of runtime behavior and giving control and visibility into that to the platform operator. And so moving it out of the world of developers, where you're like writing these client libraries and you have to, and you're kind of determining how retries work and whatever else, and pushing it down a layer of the stack or up, I guess down into the hands of the platform operators. And I think that's really been the selling point. Not that we were geniuses and we knew this ahead of time, that's just kind of how, when we see people using Linkerd, and the service mesh, that's what's really stood out to us.
No, I was going to say, I have to run and get ready for a keynote.
Okay.
So I'm going to gracefully bow out if that's okay, Alex.
Thank you, Chris. Thank you for joining us.
Awesome. Thanks for
thank you,
talking,
Chris.
everyone. It was great to meet all you guys.
Likewise.
Yeah, so I'm curious on one of the things that strikes me about service mesh technologies is this idea about how much the landscape has changed over the past 10 to 15 years, and there's kind of an analogy to TCPIP, which I'm curious about. Can you speak to that a little bit?
Me?
Yeah.
Yeah. Yeah, it's an interesting analogy because, a lot of the words that we're using are really the same. With the service mesh, we're talking about routing, right? And we're talking about load balancing, and we're talking about flow control, and these are all things that we've been talking about, in TCP/IP since the beginning of time, or, the 80s, which is the beginning of time for some of us. Not me, just to be clear, maybe Borys. So there are analogies there. I think the layer of abstraction is quite different. So when we're talking about routing in the service mesh world, we're talking about routing of requests rather than routing of packets. When we're talking about flow control, we're talking about like HTTP2 stream flow control. When we're talking about load balancing, we're talking about request balancing and not kind of packet balancing. So there's a lot of really common ideas, and I think there's also common evolution in the sense that, in the early days of like TCP programming, like you would write TCP, well, you'd write it by yourself if you're really crazy, or you'd like compile in some library into your application, and eventually that got kind of pushed down into the underlying infrastructure, and now the kernel takes care of it, and you're not really worried about that. I think we'll see a similar thing, or we are seeing a similar thing with the service mesh, where, I was an engineer at Twitter for a long time, and the way that Twitter handled these sorts of problems, was with these fat client libraries, same way that Google and Facebook and Netflix and kind of every kind of earlier web scale company handled them. And what we're seeing with the service mesh is kind of a shift of that functionality out of the application, out of the library, and down to the underlying infrastructure, which I think really parallels what happened with TCP/IP.
Questions? I know there was one right here.
It's destiny.
So I know one of the reasons you moved to Conduit was to improve resource usage. Can you tell me what's the impact to performance by introducing service mesh, as well as like compute costs?
Yeah, that's a really good question, and there's 2 answers. One, one for Linkerd and one for Conduit. The answer for Conduit is very little, and the answer for Linkerd is like kind of some more than we would want. So typically with Linkerd, what we see is there's a cost. So you're introducing not one but actually 2 network hops, right? Because you have a proxy on the client side and a proxy on the server side. You do that through localhost or something, so you don't have the full network traversal. And if you're really fancy, you can look at domain sockets, the Unix domain sockets and things. So you kind of minimize the cost on the machine of the actual network hop. But still there's a latency cost, and there's and then there's like CPU and mem usage. For Linkerd, it really depends on how much traffic is going through that thing. If you're pumping 40,000 requests per second through there, then it's going to take a couple cores, and you're going to need to give it half a gig of memory. If you're pumping 10 requests a second, well, then you can squeeze that thing down where it's taking maybe half a core and just taking a mere 110 megs of memory. For Conduit, kind of the same deal, except the numbers are way, way smaller, where we're talking 3 megs and like less than 1 millisecond P99. But it's a question of how much traffic is going through there and what's the size of that traffic. Big, binary payloads are very different from very quick HTTP requests. And then finally, it's also a question of, are you using HTTP2 or are you using HTTP1? Are you, establishing connections? Is there, how much TCP overhead is in there? So I hope that's somewhat useful. It's complicated.
Questions? We have one in the back, and any others? One right here. Lee?
Congratulations on your choice of Rust as a language.
Thank you.
It's clear that you're trying to achieve some performance there. Chef's Habitat kind of comes to mind as another prominent project that's chosen that language. I guess speaking of languages and what you've written the data plane in Conduit, can you dispel or confirm kind of the rumor that Envoy's been ingested into either Linkerd or Conduit? And then
Envoy's been ingested?
Yeah.
Oh yeah, Linkerd is just like a shell. It's just Envoy with like the JVM sitting on top of it.
Good. Okay.
Yeah. No, that's a crazy rumor. I'll dispel that. We haven't done that. We like Envoy. It's an awesome project. We know Matt pretty well from our Twitter days, and I think it's a great project. But no, it hasn't made its way into.
Thanks for making that officially good. So then a better question is, within Conduit, of the features that you guys have today, and maybe if you could speak towards the future as well, distributed tracing, is that?
On the roadmap. Yeah, actually, if you look at Conduit 0.1, which we released yesterday, it's pretty minimalist. Like, we don't even have HTTP 1.1 support. You got to use H2 in order to even try this thing out. But so there's like a lot of low-hanging fruit, on the very near-term roadmap. I think open tracing would be a pretty clear thing for us to add. Linkerd has Zipkin in it by virtue of Finagle, and so we kind of got that for free. We're going to have to figure out what to do on the Rust side, but yeah, it'll be there pretty soon.
Questions? I saw one in the back. Was there a question in the back? Yeah, there's one right there.
So other than being Conduit or lightweight, what other features compared to Linkerd is missing right now?
What features does Conduit have that Linkerd does not, or the other way around?
Other way around. Like
other way around.
What is Conduit missing?
Yeah, so right now it doesn't have any, 0.1 is missing, basically 95% of the features that Linkerd has. It does not have any request routing. It doesn't have any policy, right? And so those are two big, and it doesn't have any tracing. Those are three big things. And, it doesn't have HTTP 1 support. It doesn't have TCP support. It's like, but all those things are on the very near-term roadmap.
So I have a quick question about, can you explain the concept of reverse proxy and why is that much more relevant now, especially in this age of distributed services, distributed infrastructure?
You want to do it, Borys?
Why looking at me?
People are probably tired of hearing my voice.
Oh, that's okay. Well, in our case, with 30 years of legacy, we find that we're talking about reverse proxy, right? We found that reverse proxy is really important because it essentially allows us to add invisible and hopefully transparent layers of abstractions without user noticing that. Then how good that happens, that's another question. But essentially, it's just another layer of abstraction. That's how we see it. And sometimes we realize that we actually have like 5 years of proxy and maybe we need to get rid of a few of them. But if it's done right, then it just gives you flexibility and allows you to decouple things. I don't think that we need to aim for, putting proxies and reverse proxies everywhere, but I don't think that we should be afraid of leveraging this tool in order to do open heart surgeries on our infrastructures while we run in marathon.
Well, great. Well, listen, we're gonna end it right here, just because we've gone 45 minutes, and that was the plan originally, to have a 45-minute conversation. And I know everyone wants to get out to the keynotes, but if you ask a question, come on up to the front, and we'll give you your extra tickets. Okay? And if you don't have a raffle, so if you want to stay around for the raffle, we're giving out the prize. So Judy's going to walk around and just get the rest of the raffle tickets.
If you use the service mesh in production, you get 5 tickets. Quickly deploy. You got 30 seconds. That's good enough. Go find Jen.
What's that? Yeah. Here you go. Thanks. Hang around if you want to get a prize. If you have a ticket for a prize. Okay. Okay, the ticket number and the prize is this beautiful Pulse Rain Technology FPGA Arduino board. So by Crowd Supply. So the ticket number is 900507. 900507. Let's try again. 461-867. 461-867. Yeah, all right. Thanks, everyone. Thanks again to Buoyant for sponsoring the show, and we'll look forward to seeing you tomorrow for another Pancake Breakfast with Alcide and Chef.
The New Stack thanks Buoyant for sponsoring our Pancake Breakfast at Kubecon plus Cloud Native Con in Austin, Texas. Learn more about Buoyant and the development of its open source service mesh technology at buoyant.io. Listen to more episodes of the New Stack Analysts at thenewstack.io/podcasts. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.